Welcome to lecture 32 of the course CS213 Object Oriented Programming of the Kohat University of Science and Technology. In this lecture, we will continue our discussion of working with the files in Java, and the agenda for the lecture remains the same, but we will be focusing on practical examples and practical applications of how and where we can use file input output and how we can use reading from a file and writing to a file along with some of the concept that we learned previously, for example regular expressions. So let's look at a few coding examples of the applications of some of the concepts that we have learned so far in working with Java and working with strings and regular expressions. As our first example, we have this word counter program that is provided to you in the strings file, the code with the string files. And what this code does is, or what this program does is, it reads from a file, from a txt file that is provided to it. It reads from the file in an object of the file input stream class. We have imported the file input stream class from the java.io library, and we are storing a file from our hard disk into an object of the file input stream class. We have named the object as file. You can name it anything, but you need to provide, and here we are providing a path to the file on our hard disk. I have saved the file within the same directory where I am creating this program. If you want to see the file, here is this file within the same directory. It is the NetBeans projects and the strings, and then within that project file I have within that project folder I have stored these files that I'm working with, and this is the file that I'm trying to read the data from. If I look at this file, now this is a novel of William Shakespeare. If some of you are interested in literature and have studied read Shakespeare, this is a novel of the William Shakespeare. We can see that these are some of the characters. We can extract the characters from this text file. We can extract these words. Most of these words are separated by the commas. Most of these words are separated by spaces. So we can use these as delimiters to extract words from this novel. And maybe sometimes you would want to count the number of words that are there in a file. You would want to know the frequency of each word in a file for some reason. Then we have a simple code for that kind of an operation. In our code, what we are doing is we are reading this file into an object of the file input stream class. And now to read the data from the file, we are creating an object of the scanner class, and we are passing the object of the file input stream class to the object of the scanner class so that we are able to read the data from that file. We have created two array lists. You can use hash maps or maps. We will see at an example of that in a little while. What I want over here is, or what we want from the program over here is that we want to extract all of the words from this file and store those words in this words array list. And I want the frequency of each word, the number of times that each of those words is occurring in this other array list, which I have named as count array list. This is of type integer, and the words array list is of type string. I would want to start from 0, so the index is 0, and as I said that we can use the has next method of the scanner class to go through our file. Now it will keep going through the file as long as there are elements or there are words in the file, and it will keep reading each word into string variable word. We convert the word to a lowercase. We have used the to lowercase method to convert a string into lowercase. The reason for converting the word to a lowercase is, for example, we are trying to count to the number of word times each word is occurring in the file, and we understand that Java is case sensitive. So if you have, for example, word u in the file, and if you have a word u with the small y in the file, then Java will read these as two different words, and for that reason the program will count u with the smaller y as one time occurrence, or the frequency of u will be 1 with the smaller y, and the frequency of u with the capital Y will be 1. But since these are the same words, only the case of the word changes. You want to convert all of the letters into the smaller case so that the frequency of U is counted accurately as it is 2 and not 1. Then you use the contains method of the array list class, and you look into your array list. If the word already exists in our array list, what we want to do is we want to increment the occurrence of that word. Otherwise, we would want to add that word to it. I will ignore this statement for a moment, and I will come straight to the else statement. So what we have done is we have read a word from the file using input file.next, and we have stored that word in our variable word over here. We have converted that word to a lowercase, and we have added that word to the words array list over here, and we have added the count of that word as 1. Since there are no words initially in our words array list, therefore we add the word to our array list and we add the frequency or the occurrence of that word in the count array list. So we have our two array list over here. This will be working side by side. So we have words array list, and index 0 of the words array list we have the word, and we have the count array list, and index position 0 of the count array list we have the frequency of the word. So for example, if the word was u, the frequency that is stored at the very same index position in the two array lists is 1, and we then later on can use the index positions of these two array lists to link, for example, the word with the frequency of the word in these two different array lists. Now, since we are in this while loop, what happens is once we have written or saved this word and the frequency of the word in these array lists, we go back to the while loop. We check if there is another word or another line in the input file that we are reading from. If there is, then it will read that word in our local variable word. It will convert the word, and now it will check in our words array list. If the words array list already contains that word, what it should do is it should pick the index of that word using the index of method of the word in the words array list, and it should increase the frequency of that word at exactly same index position in the count array list. So what is happening over here is, for example, we are reading through our file and we have encountered the word you again. If we have encountered another word, for example, we have encountered R, and the frequency for that one is added as R. Now we are going through the loop again and we have encountered U again. So what happens is, and we would know that with the help of this if statement, we check our words array list, and if U occurs there, what should happen is it should not go to the else statement. It should pick the index of that word from the words array list and store it in our local variable index. So the value of the index is now 0, although it was already 0. And what we do now is we pick that index value in the count array list. So we are now at this position. We are at index 0 in the count array list. By using the set method, we get the value at index position 0, that is 1. So this statement now stores, if I highlight this has value 1 now. And what we do is we increment that value by 1. So what we are doing is we have picked the position or the index of a word from the words array list, and we have set the index position at that index position in the count array list, and we have picked the whatever the number was at that position and we have added a 1 to it. So this should now become a 2, and we would go to the next line and we will keep going through the array list or through the file as long as there are files or there are words in the array list. So for example, you are going through the file again and you encounter the word R, and maybe you encountered the other words. So let's say you have this word and then hello. If you can guess the sentence, maybe hello, how are you? Maybe not in the same order, but still. And so for example, you are going through the file and you encounter the word how again. So what happens is you have read the word and saved that in the word variable. You have converted to lowercase and whatever case it was. You check in the words array list that if it contains word, that is the now storing how, and if it has, you pick the index position of how from the words array list. Now if we count, the index position of how in the words array list is 0, 1 and 2. So the value of the index variable is now 2, and we go straight to exact that index position in the count array list. We pass that index position to set, so it will take us to this point, and what we do is we get the number or whatever that was over there using the get method of the count array list, and we increment that by 1. If we encounter how the third time, then this will become 3. So and it will be incrementing the value at the same index position. This will help us, for example, to store one word once in our array list. We are not repeating any words in our array list. We are tracing the index position of each word, and we are using that index position to store the word and its relevant frequency at the same position in the count variable. So once we are done with reading our file, we need to remember that we close our object. So for example, this is our object of the scanner class, and this was object of the file input stream class. We need to close these objects, and next thing is to store or to print the words and the relevant frequency of each word. And we can do that by going through the array list. We can go through any of these array lists, since they should have the same size, since since both of these array lists are storing the words, and the count array list is storing the frequency of those words at exact same index position. So the size of these two array lists should be the same, and what we are doing is we are getting the value at index position I, since we are going through the array list, and we are printing the word, and in front of that word we will be printing the frequency of that word from our count variable, from our count array, by using the get method of the count array or list, and getting the value of the count or the frequency of this word at index position I. So let's look at the output of this program. If you can see, it is reading the words from our file, and if you can see, it has read all of the words. So if our file has more unique words, then we can see that the frequency of those words is, let's say, 1 and 1, and then you have a large number of these words in our array list. What we are doing is we are printing the word, and we are printing the frequency of that word at the front of that word. Now if you look at this, you can see that we are not using tokenizing over here. We can tokenize these words by using this comma as delimiter. You can play around with the code that is provided in as comment that is commented out in this code. You can play around with it, and you can see that it counts pages as one separate word, then a page with, and then it counts pages with a dot, a separate word, then the pages. So you can use regular expressions to make this more advanced. So you can remove these commas and these dots from your words to make them as absolute words or the right words, convert them to right words. But this is a basic example of how we can extract the individual words from the file, and we can count each word, or we can count the frequency of that word in the file. Now let's look at the same example using a different collection. In this example, we will be using the hash map instead of the array list as that we used in our previous example. The hash map allows us to store two different data types within the same collection as against the array list that we used in our previous example. What we can do here is we can store our data in key value pairs. So we have the key and we have the value of that key. For example, if you say you have a registration number, that is the key, and this is supposed to be maybe unique, and you have the value, that is your name, that is attached to your registration number. So we can store data in this format in a hash map. We do the same process. We read the file into an object of the file input stream class. Then we use the object of the scanner class to read the content from that file, but this time we are using the hash map over here. Now the hash map, this is an example declaration of the hash map. We talked about the hash map in our lecture about collections in Java. And what we want is we want the word to be the key and the frequency of that word to be the value. So we are using a string variable. We'll be storing a string variable that will be the key, and we'll be storing an integer variable in our hash map that will be the frequency of that word. We name our hash map as map, and this is the syntax of initializing a map. We go through the file again and we do the same process. We read the word from the file if there is any, store it in our local variable, convert the word to local case, and then we use the methods of the hash map class to if put the word in the map or the hash map if it is not there already, and we use the put method for that. And here we can see that we do that within the same method call. Previously in our array list example we were using two different array lists and we were calling the two different array lists. Here we can just pass the word and the frequency of that word to our hash map object, and the word will be stored in our hash map along with the frequency of that word. If the word is already over there, then we can use again the contains method, but this time we will need to check the key set of the hash map, and that we can do by calling the key set method. What this will do is that all of the keys are supposed to be unique, so we can use the set for that. It will check the key set method has all the keys of the map. For example, it will have all the words of our hash map, and we will want to check if it already has that word that we have just read from our file. If it has that word, what we just want to increase the frequency of that word. If it does not have that word, then we want to put that word into our hash map. So if we have the word, we want to put the word again. It will put the word at the same position, and what it will do is it will get the value of that word and increment 1 to it. Now the map dot get method takes a parameter, and this parameter is the key. So for example, and as we saw in our example, we will provide the word that is the in our case the key, and this will get the value of that word, that will be in our case the frequency of the word. So if you want to get the value from your hash map, you would want to pass the key of that value as an argument to the get method of the hash map class. What it will return the value at exact same position, and then you can increment that value, that in our case was the frequency of the word, and the rest of the process remains the same, only the methods have changed. And then what we can do is, if we want to print the words and their frequencies, now in this case we want to print the frequencies that are greater than 100 only. In our previous example we were printing all of our frequencies, then we had a large number of words that were only occurring once or twice or maybe thrice. These might be infrequent words, and most of the text process examples we would want to exclude these words as insignificant words from your analysis, since these do not represent your document. But anyway, if you want to remove those words that are not occurring more than 100 times, or the frequency of those words is less than 100, then you can use the if statement. And what we are doing over here is, we might be counting all of our variables or the frequency of all of the words, and you might also want to get the frequency of each word over here. So what we do is, we use the for each loop or the enhanced for loop to go through our hash map, and we will be going through the key set of our hash map. So we are getting each word, we are getting the frequency of that word using the get method again. So we pass the value, that in this case is the word, and we pass the key, that in our case is the word, and we get the value of that key, that in our case the frequency of that word. And if we see if that value is greater than 100, then maybe we want to print that value along with the word separated by a tab, and we increment the value so that we have a count of all the words. And we want to then print all of our words, so we are printing all of our the total number of words by printing the total that we have been incrementing, and then we want to print the size of our key set. So let's run this code, and let's see if we are getting the result that we are looking for. So as I said, that we are excluding the words that are not occurring and more than 100 times from our calculation. As you can see, we have the frequencies that are mostly more than 100 over here, and we are printing the word, each word in front of the frequency. We can reverse the presentation of these words and their frequencies, and the total count of these words is you can see 22,811, and these are the unique words. Since as I said that our keys set will have the words that exactly once, so these are the words that are there in our unique words that are there in the Shakespeare column that we are trying to analyze, and this is the total occurrence of those words. So you can see that each word might be occurring more than 4 or 5 times, or reoccurring more than 4 or 5 times in or in the Shakespeare novel. So this was just another example of how we can use the file input output and some of the concepts. For example, we can improve our um, analysis by using regular expressions that can help us remove this dot from or here. You can use regular expressions or the split method of the string class to remove the spaces, to remove the dots and the commas from these words and improve your results further. Let's look at another interesting application of working with files and strings. Here we are trying to use a very simple encryption algorithm, that is the Caesar cipher. Now, if you have studied about encryption and maybe or security algorithms, encryption is something that converts our message or our email into something that is not readable if it is intercepted by a third party, and it should be decrypted when it is received by our intended receiver. Encryption is used in most of our everyday use applications, for example WhatsApp or emails. These are encrypted into a coded language or a coded messages, such that when they are intercepted midway by a third party or a third person, that third person should not be able to read these messages easily. Encryption has its own history. It has been used in wars, and it has its origin in wars where the message would be sent to the soldiers on the front line, and if that message was intercepted, it was intended not by someone it was not intended for, then it was supposed to be not understandable to that person. Here we are using the Caesar cipher. The Caesar cipher takes the input, that will be your message, and it takes a key. Now what it does is, it will, for example, if we have a message A, B, C, and if we have the key is 3. Now what should do is, it will take the English alphabets and it will add the position. For example, I have this message as 3, and I have passed the key as 3 as well. I have this message ABC, and I have passed the key as 3. So what it should do is, in simple words, it should start counting from the English alphabets, and it should replace this first word, this first character, with the third character in my message. The message should be decrypted to now D, E, F. So my original message is ABC. I have used the key 3, and this is my encrypted message now. This is what we will be trying to do with the help of our code. We will be passing a message and we will be passing a key. Now this one was a simple one. Maybe we may try to make it more complicated, so our message is not decrypted very easily by someone if who intercepts our message. Then we should convert it to a more complicated and decrypted message. So let's look at how it is done. This encrypt method accepts the message as input and the key that was passed to it. And before this, we should look at what we are trying to read and send or passing to this method. Here we are calling this method over here. So we are passing a message to this method and we are passing a key to this method. Let's look at our message. The message is something that we are reading from a text file. So we are using the buffer reader object of the buffer reader class to read from a file, and that we do in by using the file reader class. We are using the buffer reader object to store our message in the buffer in our memory, and we will be then extracting words from that message, as we can see over here. We are breaking down the message into individual words. We have initialized this message string message, and we are going through our buffer reader object line by line. We are splitting our file line by line, as we can see over here, and we are storing each word into our message variable. So now what we are trying to do over here is we are trying to remove the punctuations, we are trying to remove the spaces. Maybe we are splitting the lines into individual words or tokens, and that we do for all of our lines. As long as there are lines in our file, over here we split those lines into words, and we store all of the words in a single string variable. Now we will pass this string variable to our encrypt method along with a key, and we now go over here. The string and the key are received over here. It is converted into a lowercase, and we use the string builder class to recreate the input into an encrypted message. So we have all of the alphabets. These are converted to lowercase. Again, we are using the lowercase. We are using the substring method of our string class to create a new string with the shifted alphabet, as you can see over here. We go through the string that was passed, and we stored it in the string builder object encrypted. And what we do over here is we look at the ith character of the encrypted call. We have computed the shifted alphabet of over here. If you recall the string substring method, this is a range that we are using, and this will be the starting position of the substring up to the end of the string, and this will be the range from 0 up to the key that is provided to us. And what we are doing over here is we are reading the character at the current position. We are then extracting the index of that character that we extracted from our message in our alphabet string. If the current character is in our English alphabet string, then get the index character of the shifted alphabet. So we use our key to calculate the shifted alphabet string, and this is where we will get the index of the same character in our shifted alphabet string. So we get the index character of the shift, whatever character there is at that index position, what we do is we replace the character in our encrypted string, that was in this case our original string, and with the character from our shifted alphabet. And since this is an object of the string builder class, this is mutable. It changes when we make changes into the string, and eventually we will convert this into a string using the toString method and return this to our calling method. Let me try to explain this encrypt method again. When the message is passed as input to this method, and we also pass the key to this method. Now what happens is, what we do here is, we have the alphabet as a string that contains all of the alphabets of the English language, and we convert it to lowercase so that all of the variables can be, or all of the characters can be converted. Now since this is a very simple algorithm, we are only working with the English alphabets. Now we calculate, or we create a shifted alphabet string based on the key that has been passed to us. Now if you remember the substring method, what happens over here is, once we have this alphabet, we want to create a new string based on the key that has been passed to this method. So now the shifted alphabet will be kind of a permutation of this alphabet string based on the key that we have passed. Now alphabet.substring key, now the key over here is 17, and we understand that when we pass only one argument to the substring, that creates a new string from the argument, that in this case will be the index position in the string, up to the end of the string. And if we count from 0 up to 17 over here, so 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17. So from this position, this will create a new string. If I may, I will just copy this and I will try to create the new string. If so, this will create this code will create part of this part of the string. This code alphabet.substring with the argument key will create this part of the string. Now we add or concatenate this other part of the string, and that is from the starting position, that is 0, up to the keyth position, that is in this case 17, position 17. So what we'll do is, we will copy it from there up to the position 17, and this will be our new string. This is our new shifted alphabet string. If you want to look what the shifted alphabet string looks like, you can print the string, and then what we do over here is, we kind of replace our characters in our original string with the string or with the characters in the shifted alphabet string, by using the index position of those characters in the shifted alphabets. So it will kind of replaced, since our key is 17, it will replace, for example, this D with the so 0 1 2 3, D will be replaced by U, and so on and so forth. That is how we can create a permutation of this shift of our alphabet, English alphabet, and create a new string that will encrypt our original message. Let's look at the message that we are trying to encrypt. If I go to the file, then this is the message that we are trying to encrypt. Dear students, no matter what you may have heard, there is no news about the postponement of your projects. This is a lie, so please keep working on your projects. I have tried to divide the message in separate lines, but this is a message for you. This is the message that we are trying to encrypt. Now let's see when we run this code, what is the message that is displayed to us. As you can see, dear student. Now the key that we passed was 17. The key that we passed was 17, and it has what it does is it will add the 17 to our the index position of our current word, and it will try to repeat. For example, if we have, for example, there the first character was there, so there has been replaced with you. If you add, for example, d, the index position of d is maybe 3, and if you add 17 to it, and if you find the index position of u in our English alphabets, that might be 20, so that has been replaced by the 20th character. And same as for e, that is replaced with u, d, e, a has been replaced with the r, and r has been replaced with the I. R has been replaced with the I because once it reaches the end of our English alphabets, it will start again with the A. So if the number is greater than our final position of our in English alphabets string, it will go back to the start of the string. Now we can decrypt this message again. For example, when our receiver has received the message, they would want to receive the original copy of the message. So if we can decrypt the message by passing the encrypted message, and by subtracting our key from 26. 26 is the maximum number of English alphabets. If we pass these arguments to the same encrypt method, then we will get the same message, or the same original message in decrypted form. Now this is our original message. Dear students, no matter what you may have heard, there is no news about the postponement of projects, and this is the encrypted form of this message. If you add 17 to each of the index position, you might be able to decrypt this message. And if you subtract 17 from 26, you might be able to get the index position of your original English characters. So this was an example application of what we have learned so far in reading and writing from and to the files, and using maybe some of the string methods.